EC 111 Lecture 6, Set 4, and we continue talking about blocking assignment and how you define interdelay and intradelay using blocking versus non-blocking assignments. If you remember, we had a way to describe how you would... But the delay actually doesn't go all the way to synthesis. It's only for simulation purposes. Now, if you add, there's a difference if you add delay to a blocking assignment versus a non-blocking assignment. The simulator actually acts differently, and it's consistent with what we expect from a blocking statement versus a non-blocking statement. One thing we should always make sure is that this simulator or synthesis or whatever we do in finite state automata, everything should be deterministic, meaning that if you make a piece of hardware either in simulation or in real life, or you synthesize it on FPGA, no matter what, every time you give it the same code, it should generate the same result. So now, if that is the case, then the order of evaluations should be deterministic, and the values we get should be deterministic too. We don't want to expect any metastable or non-deterministic values out of this. Here is an example of how the delay assignment works in a non-blocking assignment. Here, we have, as you could see here, a blocking assignment assigning to value 1 to A, and then 4 clock ticks later, we assign A plus 2 to B. So this is going to evaluate the right-hand side after the execution of the previous assignment with 4 clock ticks delay. So at clock 1, we get A equal 1, and this value is then going to be used in A plus 3, A plus 2, so it generates a 3 at that clock cycle. So the sequential non-blocking assignment will postpone until the next assignment is updated, but the thing is, this is synchronized with the clock. So what happens is this also is going to wait for steps, but the evaluation will be done using the value of A right at the positive edge of the clock, which is assumed to be A equals 0, B equals 0. So what happens here is that after this, doesn't matter that we have this in simulation, B is going to get the value of A that was there when the clock tick went on before A value changed, because this is a concurrent assignment because of the non-blocking nature of the assignment. So if you do this a little wrong, you could get unpredictable result, and we are working on finite state automata. This doesn't make sense. Here's an example showing that. We are at the 4 times unit, we are going to change the value A to A plus 2, and then the same time we are going to assign to the value B A plus 3. So there's a confusion which value of A should be used for B, and this could be giving us unpredictable results, because both of these are basically going to take place at the positive edge of the clock. So but if you had this as a non-blocking assignment, it wouldn't be a problem, because you would know that the value of A is the value of A which was at 0 second. So the 0 second A was 0, so B would be 3, and A will itself the same time will get a value 2. So this will become a 2, and this will become a 3. And this is like a deterministic value coming at. So the way we should look at this is really the same notion we had with blocking versus non-blocking. Every time you have them, you take a look, you see if you have a timing that is not being violated, or the values that are changing. Is this blocking? Is this non-blocking? Am I doing concurrent assignment? And that will tell you if things are right or wrong. So here are some more examples of this. These are both kind of functionally working. Here we are assigning a equal we are assigning a equal 1, and then this value is blocking, so 4 seconds later we're gonna get b equals 3, and then this will be 3 plus 2 is gonna be 5, and but this is gonna get the old values because it's getting the values immediately. So the values we get are the values we had at the positive edge of the clock. So a used to be 0, so b will be 2, a will get the value 1, and c will be the original value of b, which was 0, so c will get a 2 here too. So the rules here is you're not recommended to use a blocking and non-blocking in the same always block. That is going to generate a lot of confusion, and that's not going to go well with the simulator either. So the other thing to remember is that delay doesn't mean anything to the synthesis compiler, because this is not a physical entity that we are talking about. This is just in simulation because we want to get an idea how things are going to work in real life. And the same variable cannot get both blocking and non-blocking assignment anyhow, because what would happen is also the same variable cannot get two non-blocking or two non-blocking assignments, because that would go immediately in effect. So this kind of race conditions are all will become kind of natural if you think about the basic notions of blocking versus non-blocking and how they assign things to them. And the delay just delays the assignment, but the basic ideas are all kind of holding. Next, we will be talking about more examples of blocking versus non-blocking and how this affects in practice.